Okay, name of the course is Computer Networks, popularly written in short as CN. And the textbooks are Computer Networks 5th edition by Tannenbaum, Computer Networks by Kuros, and Data Communications and Network by Farouzan. So let me tell you, as per your syllabus, which is drafted by JNTU, the entire 5 units you can find in the first textbook. But there are some good topics discussed in Computer Network by Kuros. Kuros is one of the authors, and he is from MIT, the top university of the world. And he has followed a top-down approach, whereas Networks by Tannenbaum is a bottom-up approach. So both the textbooks are good, but I would recommend to read the Computer Network because that is the prescribed one, and all the 5 units of syllabus you will find from the first textbook. Now coming to the prerequisites. The prerequisites of this course are nothing but fundamental courses like programming and data structures. You should be familiar with, because in some parts of the syllabus we are going to write some programs which will borrow the syntax of some programming language like C or C++. So some exposure to programming and data structures would be sufficient enough to understand some protocols which are to be dealt with in Unit 2 and Unit 3. In addition to that, you are also required to be familiar with the basic concepts of operating system and the CO. Okay, so that is more than sufficient enough, and I believe that both the subjects have already been covered for you in your previous semesters. So it is one of the core course of computer science. And the course objectives and the course outcomes have been mentioned already in your syllabus, so I don't want to repeat it. You can have a look at them. So in short or summary, I would like to say that the basic objective is to make you familiar with the networking technology, both in terms of hardware and software, but primarily more emphasizing on the software aspect. So therefore, the objective is to learn the networking terminology, the networking concepts, and the design of the network from the layered perspective of TCP/IP model and OSI model. And in fact, the whole of 5 units is based on the OSI model, if you are familiar with. Otherwise, if you don't know, then as we progress with the syllabus, you would basically come to know about it. So essentially, familiarity with the networking technology, both in terms of hardware and software, and also the protocol development at different layers, the protocol design and implementations at different layers. And it is not just networks, it is also basically all types of networks, local area networks, wide area networks, and the concept of internet and etc., with useful and supporting case studies. Secondly, what are you going to learn? What will be the outcomes of this? So I would say that the basic outcomes is that you, after pursuing this course or after completing the course, then you can aspire yourself for jobs like networking professionals, network engineers. Okay, but for both the purposes, for development and as well as maintenance. Both kinds of job you can expect, you can aspire for after pursuing this course. By development, I mean you would be able to develop network programs or develop network software or network protocols. You can become protocol developers, you can become protocol analysts, all right? And maintenance of the network, like network administrators and super network administrators, managing and designing and development, okay? Both design as well as develop the networks. Basically, the jobs like in the prominent, the most popular company in the networking domain like Cisco. So you can definitely aspire for such jobs. So those of you who are aspiring to take up jobs in the networking domain, then this course is primarily very, very important. Plus, in addition to that, those who are aspiring for higher studies, going abroad, or maybe wish to pursue MTech program here, then also this course is primarily important. So for both job as well as higher studies, this course is important. Like for example, those who are aspiring for writing GATE exam, for example, or going for MS abroad in different countries, then essentially this course has a significant weightage with regard to its marks and other things. And of course, as I said, for interviews perspective, specifically for jobs in networking domain, then this course is primarily very important. So that is the course objective. Okay. So in this lecture, primarily my objective is to talk about the introduction and background. This will be my title, where I will try to make you understand why should we learn this subject. Introduction and background is the name of the title we'll give. Okay. So where we will introduce the subject to you, make you understand why should we learn it. So essentially we are going to address the question, why learn computer networks? See, in this era, almost everybody is familiar with the philosophy or ideology of a computer network in the form of the world's largest network, which we generally call it as internet. So starting from kids to our grandparents, they are familiar with the internet, and in particular I'm referring to the World Wide Web. So there is a difference between World Wide Web and the concept and the internet as its working tool, as its vehicle. Basically, internet is a vehicle that runs World Wide Web. That is a philosophy. So later everybody say World Wide Web is a network, but it is not so. There is a different borderline difference between these two. So we would try to see that difference as such. So nowadays what I'm saying, starting from kids to the grandparents generation, they are using the World Wide Web, they are using net for different purposes, right? What are the different purposes for which the internet is being used or the World Wide Web is being used? So what are the different applications which are basically used by these generations, starting from kids onwards to the grandparents? Of course, including everyone. Some of the applications I will quote, so that from that applications you would try to make a correlation. Why should we study this course? What is the objective of this particular course? Okay, why should we learn computer networks? See, almost I will write very common applications which are in use by the people. Okay, with day-to-day life. The very prominent application on day-to-day life we use is the browser. What are some of the important browsers as network applications? Like I can use, for example, Chrome, I can use, for example, Microsoft Edge, or several others. Okay, so this is one of the network application. Then what is other network application which are used, if not by children and grandparents, maybe by other professionals like you and me and educationalists, like for example, email, communication software, in the form of maybe like, for example, you may say Outlook, Microsoft Outlook, or maybe you can say Gmail, and so on. Plus, in addition to that, we also use some entertainment software, some gaming software, like for example, for communication, I would use Skype, okay, live chats, or maybe WhatsApp, etc. Or some social networking softwares, for example, like Facebook, or maybe Twitter. So all these are basically the applications which are used prominently, and some of the applications for accessing remote services, like for example, remote execution, in the form of applications like Telnet, etc. Okay. So several applications are being used. Like what are the popular protocols? What is a protocol? Set of rules that govern the communication between the entities. This is a very formal definition I'm giving because everybody is familiar with protocol. The set of rules to be followed for ensuring communication or following some guidelines, that is called protocol, right? General meaning I'm telling, but technical meaning in the context of networks we will define later point of time. Like examples of protocols you see, like one dignitary comes from foreign land to India, like some president of US come to India. We follow a protocol. Right? The prime minister would receive him, or the president would receive him. There is a protocol for dignitaries. Now, when you go to some office, you have to follow some protocol. When you go to a restaurant, top 5-star hotel, you have to follow a protocol. Or is it not? So in day-to-day life also we follow protocols. So same way here, when communicating entities are communicating with each other, they have to abide by some rules and regulations which are given a term or a name called protocols. So like, what is the common protocol used in the browsers? In the browser we use protocol like HTTP. Just give an example. For email we use protocol like FTP, file transfer protocol, or maybe SMTP, simple mail file transfer protocol, or maybe SMTP. Now for Skype we have its proprietary protocol called Skype protocol. And for Facebook and Twitter has their own protocols, underlying communication protocols are used, and Telnet is the protocol used here. So essentially everybody uses protocols. So therefore we need to understand how these protocols are designed, developed and implemented, so that if you develop understanding of these protocols, then perhaps if you have some new ideas and new paradigms coming in your mind, you can develop your own such applications. That is what I wanted to say. So ultimately this course will enable you to develop your own sophisticated applications catering to the requirements of the companies, or requirements of the individuals, or requirements of the groups, or whatever. Okay, so if you gain an understanding how this networking software is designed, how protocols are working and how protocols are implemented, then perhaps you can design your own application. That comes under your, as I said in my previous slide, under the development part. Under the development part this comes. So therefore, as an outcome of this course, we are going to learn the functionality of this protocol, the design of this protocol, the implementation, and the issues involved in the protocol design and development. That is one aspect. Okay, but we cannot directly start with the understanding of design of the protocols as such. So we have to follow a particular approach. We have to lay our roadmap for understanding that. So first we should have a brief background on the evolution of the computer networks, evolution of this technology, and then we will understand what is the terms and terminology, then what are the components of the computer network. So slowly we build up one by one. Okay, so slowly we build up, and so that you can have a clear-cut understanding of the course. So coming to the background, about the networking technology, coming to the background, I may not be wrong if I say that the past, listen to this is slightly theoretical, but this will be very useful for you, okay? Because tomorrow in the interview, the more elaborate answer you give, the more profound approach you follow for explanation, then that will help you in all aspects. So I'm just trying to present to you the evolution of the computer networking technology, how it has evolved, and then basically we'll move forward to understand the other aspects. Let me tell you that the last three centuries were dominated by a single technology, namely Industrial Revolution. And in particular, within that, the major dominate Industrial Revolution. And within that, I would say the major one in the 19th century in particular was dominated by steam engine. I mean, this is just like a novel you can consider. I'm spending some time so that you have an idea. Basically for transportation system. But later in 20th century was well dominated by the philosophy of information technology, or information processing, gathering the information, and distribution. So 20th century and 21st century was the revolution in the industry in the form of information technology or information processing. So processing the information by way of computing, gathering the information by collecting the data, and distribution. So distribution basically deals with networking. Earlier it used to be manual distribution, like you develop the software or you develop the programs, and then you take it on the floppy drives or CDs or the pen drives, and then you carry it manually in the vehicle and give it to some other company or some other place you deliver, and at the other place you install the software and try to use it. That is also communication. So before the development of computer networks, the communication was done in that fashion. But later with the coming up of the networking technology, it has facilitated, it has totally avoided the physical transportation of the data to online transmission through communication channels or through communication media. So later in the 21st century, further development took place in the form of, 20th and 20th century together, further development took place in the form of establishment of very wide, very popular network by name telephone network. So before the computer network, what came into enforcement was telephone network. Then the invention of radios, radio network, invention of radio. Okay. So this has facilitated or laid a path for an effective platform for computer industry, satellite communications, and so on. So I'm telling the chronology as to how the various developments took place, which has facilitated or helped the growth of the computer networks. Okay, so before the era of our computing technology, the network technology, we used to have earlier standalone computing. Standalone computing. Before the development of computer networks, what was prevailing, what was existing was standalone computing. We used to have a huge machine. So first it started with small machines, and then later it started with, you can say, mini computers, and then microcomputers, and then supercomputers, and so on. Okay, so the cost of supercomputing was enormous, were very tremendous, and no individual or even small companies can afford to it. Very big companies only, very big organizations only could afford to have such big machines to perform high-end computing. So in view of that, so it has been replaced later by what we call interconnection of computers. Like I have one computer here, one computer here, another computer here. Not the mainframes, or not the supercomputers and so on. Almost your normal PCs, PC1, PC2, PC3. So the basic idea is, if we can interconnect them, for example, by means of some communication channel, for example, then what are the several benefits of this approach of interconnection, The basic benefits. Like number one, I can primarily say I can share the resources, right? Where people working on different computers can share the resources. Plus, they can even distribute the computing. The task can be broken down into several tasks, and then the task can be distributed on different machines, and I can accomplish my job. So whatever job I can execute, on a big machine now can also be executed on this non-costly machines which are interconnected, which has given rise to the basic foundational idea of a computer network. Okay, so why should we spend huge amount of money in having sophisticated high-end superscalar architectures or supercomputers or big computers? So rather than that, take non-costly machines and interconnect them, and then you try to utilize the resources by way of communicating with them among themselves, and also distributed the computing task into different machines and get your job done. So whatever jobs were being done on a big supercomputer now can also be done on a less costly interconnection of computers. So this setup has given rise to the notion of what we call computer network. Okay, so from this I can formalize now the definition of computer network. I can formalize the definition of a computer network. So what is a formal definition of computer network? Okay, so it goes like this. It is an interconnected collection of autonomous computers. Interconnected collection of autonomous computers. Now there are two things that you need to understand. One is interconnection and the other is autonomous. When I say computers are autonomous, then that means there is no master-slave relation. Between them. They have their own independent processors, they have their own independent memory, as such their own independent operating system also perhaps, or I can load it, and then autonomy means they have all independence to carry out their task. They don't depend on any master server. That is the meaning of autonomous. And two computers are said to be interconnected if if they are able to exchange information. If they are able to exchange information. Okay. So this is the meaning of these two words. So if somebody asks you what is the meaning of computer network, you don't say collection of computers, or you don't say when we connect one computer to another computer. There is a layman definition. But as a computer science or IT professional, it is more appropriate you define computer network in this way. Interconnected collection of autonomous computers. There are two things here, two keywords here. One is the meaning of interconnection, the other is meaning of autonomous. Autonomy means complete independence, have their own independence as such, and interconnection means they should be able to exchange information among themselves. So this is a formal definition of computer network. In addition to that, there is another term similar to network which is called distributed system. So let us talk about distributed system also, because people may question you, what is a distributed system? This is a very popular question. What is network and what is distributed system, or differentiate between distributed system and a computer network? So let me explain to you. Now, first point, distributed system is also a computer network. First point is also a computer network. So I'm writing short network like this, so I hope you follow. But the existence, please follow me carefully, the existence of multiple computers, okay, is transparent to the user, That means, I will explain it diagrammatically. In the case of a computer network, suppose if these are the machines which are interconnected, okay, which are interconnected by some communication channel, let us say. So if one user is sitting here, in the case of computer network, he will know how many computers are there and what data is residing on these machines. So user knows everything in the case of computer network. Existence of all the resources will be known to the user as such. But in the case of distributed system, like now if I say this is a distributed system, the existence of multiple computers will not be known to the user working at any machine. What resources are present will not be, and where the resources are present will not be known. That is the meaning of transparency. So that means the user will get an impression for distributed system that he is working on one big machine, one machine only. That is what I say, the existence of different machines is transparent to the user. So user will get an impression as if he is working on a big machine and all the resources are available to it. Then who will provide this transparency? This level of transparency will be provided by a distributed software that runs above the network. So that means the typical architecture of a distributed system of a computer in a network will look like this. Suppose if I say this is one computer in a distributed system, then at the lowest level I have the hardware of the computer, which include processor, memory and so on. And then over and above the hardware we have the operating system. And as part of operating system I will have the network software, the protocols. And then this will be the architecture for normal machine in a computer network. Now for a distributed system, I will have this layer of software called distributed software. This is an additional thing which provides transparency to its users. So that is the relevance. So this could be a simple 2-mark or 3-mark question in your exam. What differentiate between computer network and distributed system? Computer network, the transparency is not provided. Every user will have to explicitly log in into the machines, move the files physically. So user should know everything, programmer should know everything, where the data is present, on which machine and so on. Whereas in distributed system, the existence of the resources will not be known to the user. The user will get an impression that or illusion that he is primarily working on one machine. Okay. So the existence of different types of data is not known to the user. Okay, so that will be taken care by distributed software. So this will be the architecture of computer network. So if I add distributed software to it, then it becomes distributed system. So distributed system issues are slightly different from that of network, because there we focus not only networking technology but also the design of this distributed software. So this will be generally taken up as a different subject as an elective in your final year called distributed systems. So that is a new advanced computer network subject called distributed systems. So this is the meaning or the concept. So I've given you the brief background of how the networking technology evolved from the past 3 centuries, and then the significance of networks in comparison to standalone computing, what is the benefits of it, and then I formalize the definition of computer networks and distributed system. Okay, and then the next thing that comes before we take up the design aspects or the terminology of networking, we have to understand what are the uses of computer networks. Why should we use computer networks? Where are computer networks deployed? Followed by a brief taxonomy, brief terminology. Okay, so that's it in this lecture.